they will burn acres and acres. They'll burn whole fields just to get that out, to stop it from spreading. What might seem like a small amount has a great impact on yield.
Greetings, Earthlings, and welcome back to Earthlings 2.0, the show where we imagine how we can be better versions of ourselves and build a collective future we actually want to live in. Today, we're exploring the innovative world of agriculture and robotics, combining that with AI and solar power for more sustainable weed management. I know that sounds like a lot, but the ultimate goal is reducing the carbon footprint of agriculture and also helping to regenerate the soil, which is also a natural carbon sink. And of course, the downstream effect of this could be that our food is healthier because it wasn't grown using chemical herbicides. But before we get there, I'm your host, Lisa Ann Pinkerton. I'm the CEO of the award winning PR firm Technica Communications and the founder of Women in Clean Tech and Sustainability. Prior to this, I was an award winning environmental science reporter for NPR and PBS. And if this is your first or 50th episode, thank you so much for spending time with us each week. We love bringing you all this really cool information. At least we think it's cool. I hope you think it's cool too. You could tell me if you think it's cool or not if you want to take our listener survey or join our Substack newsletter and send us an email about what you think about the show. All that information is in the show notes for you. And if you are enjoying this show, please consider recommending Earthlings 2.0 to a friend of yours. The next time you're talking podcasts, or the next time you're just talking about some information that you learned from the show, feel free to cite us. Share the show with a friend. This is singularly the best way that you can give back to the show and help us grow the community. And thank you to Resource Labs for having us on the network. Now, let's dive into today's topic. Our tech spotlight is with Aigen. This is a startup that has a very innovative approach to agriculture using advanced computer vision and AI to spot and eliminate weeds without the use of chemicals, all while being powered entirely by solar energy. Their robots can operate up to 12 hours a day, and this provides a more sustainable and efficient solution for farmers compared to just arbitrarily spraying herbicides and praying that it helps. Our guest today is Usman Khan. He's the founding engineer and senior data scientist at iGen. His background is in building efficient AI systems and enabling autonomous intelligence at the fraction of the resources that it traditionally takes. Welcome to the show, Usman.
Hi, thanks for having me.
Thanks for being here. I think what you've developed here is pretty cool. And before we get into these autonomous solar-powered robots, let's get a lay of the land. What are the challenges in the agricultural sector that motivated you all to develop this technology?
Yeah, that's a really interesting question, just because agriculture, the nature of it is we often don't think about it, but there are so many different angles to it. If you really consider it from a historical perspective, agriculture is the bedrock of civilization to the point where even a lot of the ancient societies that we study became who they became just because they happen to have more fertile land than in some other regions. And so really everything that we build comes from agriculture. What we started to see recently in kind of our day and age today is that there are a lot of problems with the direction things are going in. A lot of that's coming with needing to support populations and going more towards these industrialized systems that we're starting to realize, like with many other industries, that are just not sustainable for our future. They're degrading our land. These systems are also polluting, in a sense, our food as well as the environment in a variety of different ways. But the thing is, it's easy to kind of demonize these processes and think, wow, this is such a horrible thing. But what we need to consider is like, what's the solution? Like, why is this happening? It's not the case that people in the ag industry are like, you know what, let's just ruin the world. That's not what they're trying to do. It's that they have to go to these. I mean, it sounds funny, but a lot of people like they'll think that way and they'll kind of
Hmm.
approach farmers without that sense of empathy. But we need to really understand like these solutions are out there to deal with certain problems, right? how are we actually going to produce food, dealing with all types of things. And the biggest problem in agriculture is weeding. And that is kind of where everything is centered around. Weeds will take over a field, completely destroy your yield. Weeds can sound like cute in a garden, but when you get out there in the field, that is like a whole livelihood that can disappear very, very quickly if not managed correctly. When we talk about these technologies that are having harmful effects to the environment, whether that's spraying herbicide or whether that's tilling up the land and things like that, really the primary driver for all of that is there needs to be a way to manage weeds so that we can grow enough food and have that make sense. So that's where everything is coming from. And we looked at that and considering this whole system with all of its downstream impacts, what is the one thing that we could do to solve that problem and to enable a future of agriculture that doesn't depend on these types of things? And seeing the opportunities that we have now with autonomy, with new emerging technologies, that's kind of where it came from is how do we create this win-win situation where we are helping the farmers the problem they already have, uh, which is managing weeds, especially because the chemicals they're using now are also starting to fail. Weeds are evolving resistance. And so what happens is they evolve resistance. We need to spray harsher and harsher chemicals, and this keeps going until it becomes an untenable problem. So one is we're solving that problem even just from like a production standpoint. But beyond that, we're trying to create this win-win situation where that solution, even though it's a win for the farmer, is also a win for the environment because we want to create this approach that will manage the weeds without doing the harmful effects to the ecosystem that some of these other systems that we've traditionally had are creating. And with modern capabilities and technology and applying intelligence, we can create a system that instead of fighting the environment is working with it and is kind of rehabilitating the land simultaneously while creating greater yields for the farmer. And so that's kind of where the concept of the product came from.
And you're right, because like in a garden, weeds are just, it's like you pull them because you want it to look pretty. But in an agricultural operation, these weeds are taking nutrients away from the crops that you're attempting to grow, and they're competing directly with those crops. And that's how it can reduce the yields of the farm.
Yeah, it's pretty nuts because I think it takes going out there to really see the magnitude of the problem. I remember a farmer once showed me like a whole field, like far as the eyes can see. He's like, we lost everything on that field because of weeds, right? To the point where even we've had some farmers tell us that because of a specific herbicide resistant weed being introduced on a farm or a field, they will burn acres and acres. They'll burn whole fields just to get that out, to stop it from spreading, because that can become like a problem year after year. Even what might seem like a small amount has a great impact on yield. It's pretty nuts to deal with the kind of the scope of the problem. It almost feels like you're at war with these weeds.
And burning a field just adds even more carbon dioxide to the atmosphere, and we don't want that. So let's talk about these solar powered robots that you've created. What do they look like? How do they operate?
The key here behind being solar powered and autonomous is that our robot is truly autonomous in the sense that you can drop it and you let it go, and you don't have to fuel it up. You don't have to intervene on it in that type of way by giving it other types of inputs. So it's a zero input solution, meaning that it completely sustains itself. It's powered by solar in the day, in the morning it wakes up, it weeds all day, at night it goes to bed, and does all kinds of data crunching and processing at that time. What does that enable is now we're tying the ability to have this type of management on the field to the technology itself and not to people. You don't need to have more staffing and more people to accomplish this. You can have these robots roaming autonomously. And that also enables like a lot of other things. When you see the scope of a farm, it's like massive. To even understand what's happening on different parts of the field requires a person going out, spending a lot of time to be able to even get that information. So it's two things. It's managing the weeds, taking action, but also getting this data. And so we're taking the data that we're collecting and we're converting that to not only actionable insights, but actual action, right? We talk a lot about insights, but the action piece is missing for a lot of people in a lot of industries and companies and stuff like that. But that's where the real problem is. So it's kind of a not even two birds with one stone, maybe like several at the same time. And that's sort of how we try to design everything and what we're trying to accomplish with these fleets of robots that can get coverage.
Break it down for us, Usman. It's a solar panel and it's got wheels on it. And then I assume there's sensors and things underneath the solar panel, but it basically just looks like a solar panel on wheels.
It's kind of like a self-driving car, but it is like it's optimized for agriculture. It's pared down. It's really simple. We went with this really simple design, and there's a few reasons for that. One is this theme of autonomy, not having the farmer have to operate these robots. And so as simple a design as possible so that it can roam autonomously and manage the weeds. It's got the wheels, it has sensors, and it has two mechanical arms. And these mechanical arms are kind of driving and removing the weeds mechanically. So they will always work in the sense that you spray a chemical, a weed will evolve resistance to it. I mean, what we often say is that there's no resistance to steel, right? So it'll just cut the weed out. It's a tried and tested method that's existed for thousands of years, right? Like you might go into your garden, you take a hoe and you take the weeds out. So that's what it's doing. Other notes about the design is that we want to keep it really simple and low cost. So in robotics, we often hear this promise of robotics. I mean, you might have been hearing it for a long time that robots are going to do everything in the future. One of the reasons why that is not the case today, where you don't see robots doing everything, is because a lot of people in the industry have ignored the hardware challenges. They have said that, okay, we have all these fancy algorithms, now we'll go build this robot for it. Now you have like a $2 million robot that no one wants to buy. Who's going to buy a $2 million robot to fold your laundry, right? Uh, so that's kind of the approach that we've taken is that we want this to be super scalable. That, for a small farm, you can have a few. For a large farm, you can have hundreds if needed. And they kind of roam around the farm and take things out while also providing data. One other thing that I'll mention about it is that we often get this question when you see robot, well, why is it so small? It's not tractor sized. Um, and the reason for that is traditionally we are used to thinking of farm equipment as being large and heavy. And that makes sense because you want to maximize your man hours, right? If you are manually driving something. But when you have autonomy, that no longer makes sense in the same way. Rather, you benefit from having a distributed system that gets you coverage and information all from the farm. You don't have to wait for someone to go out to one end of a farm to another. You have these robots always roaming, giving you data that will improve your operation while continuously roaming and removing weeds as they come up. Sort of like a Roomba for the farm is one way we've described it.
It reminds me of a concept that I learned around robotics where this person was saying, look, people think that robots need to look like humans and be, bipedal and have arms and a head. And actually, probably robots of the future aren't going to look like humans at all because you can be a lot more efficient and effective with whatever task you're going after if you just use all different types of shapes. It's interesting that the farmer, like you said, could just set it and forget it. So I'm curious, after the robots are set in the field and their little wheels are following the lines of the field and pulling out weeds, can the farmer then go and do other things? And do they get alerts or any type of notifications on their computer or phone if there's something wrong? How does that portion of it work?
So right now it's a fully managed service. The farmer doesn't need to worry about it at all. The robots will drive around, do their thing. If they get stuck or encounter a problem, they will send a notification to us, and we as a team, we have a team right now that will resolve the issue if the robot needs help.
How many acres of farmland could a robot cover in the 12 hours that it can be powered?
So there's a range. and it just depends on a few different factors. Like it depends on how many weeds there are and what's the density of them. Should the robot focus more on one area versus go to another area? So these are all things that are sort of in flux, but what you can imagine is if you have like a 100-acre farm, then there'll be like a handful of robots.
And I understand that you are piloting your robots right now in North Dakota. Can you tell us how they're being used and what's the experience that those farms are having?
Yeah, so this was our first season operating with actual customers on real scale farms. That was the experience for them. It's like sort of like I mentioned, right now we are a weeding service company. You tell us, hey, we want you to weed X amount of acres, and we're like, okay, we'll do that. We send our robots out there, and so we set up this operation. We had about 60 robots built this year that we deployed in various places within that specific region. They would roam autonomously and collect a lot of data as well while weeding. I think one of the really cool proof points that we saw is that like we proved that this can happen. We can have like one operator or one person, not necessarily even an operator, just monitoring like a fleet, right? Monitoring several robots and only intervening when the robot says, "Help me, I'm stuck," or something like that. And it's shown really the vision of how this can scale in the future, right? This is like we're just getting started, and so soon we're going to be like really ramping up and scaling up the numbers. So that was really promising to see, and I think it's going to be pretty exciting.
And I talked earlier in the intro about how using these robots to weed fields reduces the carbon footprint of the farm. And that's because we're not using as many chemical herbicides, I assume. Let's talk a little bit more about that.
Yeah, there's a couple pieces to it. I think one of the really interesting things is that when you investigate it a little bit, and there's been some work that I saw recently at MIT about doing some like modeling and simulation of different things, the effect of different things in climate. Agriculture is a big one. It's like massive. So when we think about like emissions, even well, we have to appreciate that, traditionally what's happening is that people are driving these big, heavy diesel-powered machines, right, as many times as needed to get things going on these huge plots of land. So that's a huge driver. The other thing is that if you look at a map of land use in the United States, for example, you'll see that so much of it is agriculture, right? For those of us who live in the cities, it's easy to forget, but really, like most of America, if you're looking at it, is just agricultural land. And so that has a huge impact, right? Huge impact. Uh, from the operational perspective with the machinery we're using, but also from the land itself, right? In its, maybe I want to say correct or natural or optimized state, soil should be a carbon sink. It should be using carbon to create vegetation and an active participant in the carbon cycle. Uh, However, when we start doing things to the soil that are not naturally meant to happen, like large scale, deep tilling, over tilling, over farming, and stuff like that, then we start messing with that cycle, right? We turn this soil from being a carbon sink into being, in a sense, an emitter because you're just releasing the carbon from the soil. Uh, and that degrades more and more. More and more land becomes desert and degraded, and then no longer arable for farming. So, with a solution like ours, the goal is that if you can manage your weeds without doing those things to the soil will rehabilitate and it'll become its healthier version of itself that is then able to then create these effects, right? And harmonize a bit more with the environment. So that is sort of the goal. And if you apply that at scale, then you can really start to see an impact. What we like to often discuss is that if the whole world even just like went electric right now, we're still not solved, right? On carbon. We still need to do something other than stop emitting. We need to actually start rehabilitating the cycle itself. And so that's the goal with these robots once we're able to scale them up.
And we're a futurology podcast, so I want to ask you this question from your vantage point, being an engineer. of these robots. What do you see coming in the future related to agriculture, AI, and robotics? Not just from your technology, but then other things that you're seeing or the opportunities that are presenting themselves.
We've reached a point where it's inevitable that something will happen to change agriculture just because it's unsustainable to continue the way things are right now. Uh, we're already seeing issues where, certain governments have wanted to ban things like glyphosate. The farmers are like, we need this, otherwise we can't do anything. So there's like a clear, very, very strong need. And in response to that need, technologists will build. Like that's going to happen. It's up to us to make sure that that is steered in the right direction, right? Because technology as a force, it can create many, many different types of effects. And so I think we'll start seeing, more of this, and we are seeing it that you're going to have robotics companies, like us. There's a number of players in the space, but you're also this kind of intelligent or digital future of how farms are run, right? That is, I think, something that's coming as well, is understanding with this data the farm better, the interactions with, various effects, weather, et cetera, and being able to leverage that with AI, with, modern computation, to be able to do things in a more intelligent way, right? When we talk about ourselves as a company, we say what we're doing is AI generated agriculture, right? The real use case here is creating something is taking this data and converting that into action and figuring out what the best action is to take and efficiency, right? Efficiency at scale will then create this situation where we can harmonize with the environment. But I think that's going to happen a lot in a few different shapes. There's drone companies, there's, tractor companies, there's a lot of other people trying a few different things with different approaches. And I guess time will tell what will actually be uh, the best type of the best type of approach. There's saying that our culture moves at the speed of trust. So yeah, we'll just have to see. And farmers as a group, they are very much about, is something going to work? It's not about how flashy it is or how cool it is. Is it going to work? Right? And so I think whoever is able to, or whatever group it is that's able to solve that problem, we'll see a lot of adoption.
As a population, pardon the pun, farmers are very down to earth when it comes to the technology and practices that they employ. They know what's going to work or they know what they need, and they are often not swayed by things that are flashy. They're very practical, which I appreciate because they got a lot. There's a lot of variables that they're dealing with and a lot of risks that they often take. Thank you so much, Usman, for being with us today and sharing this work that you're doing. I think it's really cool, and we will keep track of your developments and see how things play out for you.
Thank you. It was great being here.
And Earthlings, we will see you again on another turn of this beautiful blue-green space flower that we call home.